All right, so in this video, we're going to look at linear patterns from a table. First thing should be super quick, and that is fill out the table based on a given equation. So when you actually have the linear equation and you have a table for certain values, that is just plug and chug, just like if you were using it, to graph, which in this case we're not graphing. But in this particular example, we have our table as -3, 1, and 5 for x, and you're supposed to fill it out based on this pattern. Now, please, 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 you need to make sure that you show work for these types of things. So when I plug in the -3, just right over to the side, -6 times -3 plus 5, so that gives me 18 plus 5, which gives me 23. Then move on to the next one. So -6 times 1 plus 5. So -6 plus 5, which gives me -1. And then the last one, -6 times 5 plus 5. So this is -30. -30 plus 5 is -25. And so then this would be our answer. We've completed the table. We showed our work. Hopefully that one's pretty straightforward. The other ones that we're going to look at today are when the table is filled out and you need to decide if the table that you see is forming a linear pattern or not. So let's write out the directions here. And I might type them because it's a little faster for me if I do that. Okay, so decide if the table forms a linear pattern, and then you'll always be asked to explain. Okay, and that should just pop up, I think. Maybe. There we go. All right, so our first table got x, y, 1, 0, 2, 2, 3, 4, and 4, 6. So here's our first table. And when we're looking at these, I think that the big key words that hopefully your Algebra 1 teacher used in that course is that linear functions or linear equations have a constant rate of change, which hopefully you can kind of regurgitate that saying. But I found that a lot of people really don't understand what that means. So they look and they say, oh yeah, it's going up by 2 every time, definitely linear. A constant rate of change means that for every same increment of x's, you go up by the same number of y's. So that is only true of the y's if the x's are also going up by the same amount. So here, my x's are going up by 1, by 1, by 1, and this is going up to 2. A constant rate of change isn't just this part. This part is just the change in y. A rate of change is the change in y divided by the change in x. Because these are both the same, we can definitely say yes, it has a constant rate of change of 2 over 1 or 2. So this one would be a yes. I don't know why I just tried, I'll show you, I'm trying to change the color, but it's not letting me for some reason. So this is a yes. And this is a constant rate of change of 2 over 1, which is 2, equals 2. Okay, so now let's look at a different table. Ooh, it's not straight at all, sorry about that. So 2, -1, -4, -7 are our x's, and then we've got 8, 5, 3, and 2 for our y's. Now, as we look at these, again, you're looking at the change in y's versus the change in x's. So here, from 8 to 5, I went down 3. Here, I went down 2, and here, I went down 1. So this isn't necessarily bad if the change in x's isn't constant. So we need to see what that is. So from 2 to -1, that's -3. From -1 to -4, that's -3. That's -3. So here we have the same change in x's, but we do not have the same change in y's. So this one would be no. And I would just simply say the rate of change isn't constant because we've gone from having -3 over -3 to -2 over -3 to -1 over -3. So they're not the same, which is not what we would want here. All right, next table that we're going to look at, we've got 7, 5, 3, and -1, and then -2, 1, 4, and 10. So when we look at these, our x's, this is going down by 2, down by 2, and then this one went down by 4. This then went up by 3, up by 3, up by 6. So when I look at these, my rate of change for the first pair is 3 over -2. So is the second pair. Now, the third one is different. So I get a lot of people here that will say no because it's not the same, but it is. Because 6 divided by -4 is the same as 3 divided by -2. So the rate of change stayed the same. It's just that I made a bigger jump. So this is yes, constant rate of change of 3 over -2, because we would always put our rate of change in simplest form there. So this one would be a yes. All right, last one that we're going to look at. Apologize for the very messy writing. It's hard to write on this tablet sometimes. 4. Okay, so here I added 1, added 1, added 3. Here I added 1, added 1, added 1. Okay, so my y's stayed the same, but here my x's did not. So this is not a constant rate of change. No rate of change, not constant, because 1 over 1 is not the same as 1 over 3. All right, so hopefully that clarifies. It's not always just the y's being the same, because here the y's are the same, and so are here, but this is a yes and this is a no. And just because the x's are different or the y's are different doesn't mean it's always a no. This one's a no, but this one's a yes. So make sure you look at both and that you're looking at those gaps to see if it's constant.